So welcome everyone to Developers Meeting on October the 5th, 2025. Today we do a quick intro into camera optics because discussions arose yesterday and the days before about certain cameras, whether they are capable of UAP tracking or tracking per se. We have a page on our website that explains it actually and has calculation functions. And we always refer people to this page, not to ask always the same questions. So we thought, why not make a quick video and explain it in detail, what's going on. So I'm not going to share my screen. So, yeah. Do you see what I share?
Yeah.
Okay, cool. So this is the page, skype60.org/tools. It's always also found in the menu, tools. So first of all, it asks, how big is an object in angular size? To answer this question, we have some selections. Let's start with an Airbus A380 on 12 kilometers distance. The object is, when I selected, 73 meters in maximum extent. And let's keep it on 12,000 meters, for example. So when we calculate, we got an angular size of 1,254 arcseconds. And now to the next question, which is, does a certain object resolve the object by being compliant with the Rowley criteria? So first of all, we need the optical diameter, aka aperture, but actually optical diameter. Let's go with this camera. This camera has a zoom. It goes from 5.5 millimeter focal length to 248 and has apertures of 1.5 to 5.3. So let's start with on the low end. Hoppla. So let's divide. Christian, please, when I do anything wrong, please interrupt me. I divide 5 by 5 by 1.5, and I get the diameter 3.7, let's say. Coming back here.
Millimeters.
Millimeters, yeah. 3.7 millimeters. The calculation is based on the wavelength of 0.00055 millimeter, which is, I think, 550 nanometers, somewhere in the red, right?
Yes.
Okay, calculate. So the optical...
No, it's green. 550 is green.
It's green,
because
so, yeah, it's in the center.
Because the human eye is most sensible at 550.
Okay. So now the optical resolution is 37.41 arcseconds, means this fits in here quite nicely. So the optic can resolve the object for tracking. The optic can do it. Question is now, does also the sensor resolve the object? So sensor pixel size. Where is this pixel size? Okay, yeah, it doesn't state here on the product page, but I found out that the pixel size is because they are using an IMX334 sensor from Sony, that the pixel size is 2.0. So we entered 2.0, and we have an optical focal length of, what did we just say? Optical focal length 5.5 at this point for the low end. 5.5. And we calculate so that it has now 75 arcseconds. And which means that on any sensor, whatever resolution there is, this object is resolved by 16 pixels.
That's not much.
Yeah.
That's just the bulb of pixels.
Yeah, it's just that
no details.
You see, but it's not zoomed, it's on the low end. So
yes.
This camera, we're talking about this one, has a zoom 248. A calculator. 248 by 5.3. 46.79. 46.79. 46.79. Calculate 2.96 arcseconds, which is much finer. And of course, this fits very, very often in this angular size. Sensor pixel is the same. Focal length is not different. 5.3. Oops. Oh, I made a mistake before. 5.5 optical. No, wait a sec. I'm confusing myself.
Millimeters.
No, 248. No, it's correct. It's correct. 248. My fault. Oh, everything's good. So the angular size is 1.66 per pixel, which means the resolution of the object of this camera, when it's full in zoom, for an Airbus 380 on 12 kilometers height, is with about 755.89 pixels. Okay, so that gives you quite a good resolution, and that's why we can say that this camera, for example, is good for tracking objects, even I think manually tracking objects.
But only at 12 kilometers distance.
Yeah, true.
12 kilometers distance is, you're standing next to an airport.
No, 12 kilometers distance is the average flight, so the normal flight operation level. But it means that it's directly over you. Yeah, it's directly over me. Yeah, I get it.
If you're standing here and it will land within a few minutes, then it's down below here, and then it's distorted.
Yeah.
So the distance is a radius of 12 kilometers.
Yeah. So let's say
the object if it's further away, let's say 200 kilometers, it's, let's say, 30 degrees above horizon, where the limit is that you can, the seeing limit is that you can exactly pinpoint an object, then it's different. Because in 12 kilometer distance, it has 1,200 arcseconds of diameter. Calculated with a realistic distance of the plane for, let's say, 200 kilometers. And then things look very different.
So let's say it's a... So here, let's say it's on 45 degrees. Not on 30 degrees, let's say on 45 degrees. Then the distance is 16,800. Right?
Now make it 200 kilometers.
Well, it's far. That's on the 30 degrees.
But it's realistic.
Okay. Is it 200,000? Yeah, 200,000, right? Yeah.
Yes.
Correct. 200,000. And then it's only 75 arcseconds. But this is the extreme, I would say. Otherwise...
No, it isn't. It is not an extreme. It's realistic.
In 200 kilometers distance. Okay, let's see what's come out. We have 75 arcseconds of resolution of the object itself. Yeah. The zoom with this camera, it's with this optical resolution of 2.96. It's still fitting in here a lot. Rest is still the same, and the object resolves with 45 pixels.
Okay.
But this is a dancing because there's so much atmosphere on this distance that 45 pixels is a smear, I would say.
Yeah, you can't resolve it.
Yeah, but when it's on 45 degrees, let's say when it's only at 20 kilometers distance.
But 20 kilometers distance, yeah, nice, but the farthest you can detect is such an object, and it's a huge plane.
Yeah, the question was not for you. Sorry, okay, I have to set the scene right. The question yesterday was about tracking airplanes. It was not about tracking UAPs. That's right.
No, it's about tracking airplanes.
Yeah.
Yes.
So when we go to an orb, for example. So maybe Dave, you can correct me now. An orb, I say it is a 4-meter diameter thing. It's in 5 kilometers distance.
An orb at 5 kilometers, you're not going to see it.
You're not going to see it.
It's not that big.
Yeah.
You know, I'm going to use English. 2 to 3 feet is the average size. Now I have captured at 8 foot.
Okay, so make it 1 kilometer distance. It's 200 arcseconds. So with the same camera, the same zoom, can still resolve it, the optic, because it's 100 times fitting in. And it's resolved on 124 pixels. If you, of course, can keep it in the eye of the camera. Yeah, so let's do it with a drone. Drone, 1 meter, 1 kilometer, right? That's the value of a drone, let's say. 1 meter, 1 kilometer. But if it's far away, let's say on 5 kilometers, you won't see it. I think. Oh, it's still with 41. With this camera, yeah, we're talking about with this camera, with this one. This one. I just want to find out where's the limit from this camera. Let's say a 1 meter object in 10 kilometers distance. Still 20. So let's make it 10 times. Let's say 100 kilometers. Now it falls under the, yeah, half it. Okay.
Yeah, 1 meter is a large drone.
Oh, 10 kilometers. Oh, 10 kilometers. Something around the 10 kilometers already. The breakpoint for this. So when you cannot track a UAP, let's say an orb, with this camera when it's in a distance larger than 10 kilometers. But within this range, the optic should dissolve it. And it's still 12 pixels on the sensor.
Yeah, but the resolution is not good enough that you can see any details on it. It's a blob of pixels and just a few.
Yeah, on the drone. But the question that was discussed yesterday was about the plane. Let's keep it on 20 kilometers distance. I think that's, oh, selected first. Yeah, let's keep it on 20 or let's see, 30 kilometers
20
distance.
Kilometers is very, very near. You can see it with your naked eye and resolve it with that.
Of course.
What good is a camera for that then? You take out binoculars, look at it, and say, yes, it's an Airbus A380.
Yeah, but the question, Christian, is not about an automated system, so that you have a fish eye that has to resolve the object first and then control the PTZ and direct it to.
Yeah, that's our solution. That we say, okay, let's detect it as there is an object, and then take a closer look at it. This is our approach.
Yeah. So, what the question? The question from yesterday.
They want to take a look at the planes and identify the plane.
Yes.
What type it is.
Yes, and
can I show you some results of our camera system we're using that Ron put up in the last couple of years? I got 2 quick videos I can show you. They're on YouTube, by the way.
Yeah, can you tell us the camera?
The first one is the 5230. I have the 5232. So this is a 30 times zoom. I have the 32 times zoom. And again, running at 1080p. So where's the share button? Share your screen. I want to share this one. Let me know when you can see it.
Coming.
Yeah. So this is a typical non-zoomed in photo to start with, and we're not going to zoom in it yet. I'm just going to show you what was caught.
Wait a second, Dave. I still don't have it.
Not here yet. Yeah, I know. I see.
I still don't have it.
Yeah, I see that. It's taking forever. And I got 500 megabit download. It's Discord. Come on. It's still circling.
Mm-hmm. Do you have a YouTube link? Now it's coming.
There we go.
Here we go.
All right, so just watch this for a second. This is an airplane.
Yeah.
We're not going to zoom in on it yet, but the camera's a little shaky because it's windy, but it's tracking it perfectly. And look how far away it is. And then what you missed is this. Woo! Nobody saw it with their eye. It was determined to be a UAP.
Mm-hmm.
And the first one, this is what we zoomed in. This is our resolution of that camera, the same, 2017 or whatever it was, no, 2019. So zooming in, this is what I got. So you can definitely see it's an airplane.
How far was it away?
That's coming into Toronto International, so it's 18,000 feet up and over the lake, which to me is 8 or 9 kilometers away, and then looking up. So you're talking 12 kilometers away, 12, 14 kilometers away. That's what I zoomed in to see.
Yeah, okay, but it's 12 kilometers. That's nothing.
Yeah. No, I know, but still, it's clear as day. It's an airplane. That's all I care. No, you can't read the tail. You can't tell what plane it is. Well, you could if you're really good, but I'm saying
I would say it's a 767 Boeing.
Yeah, that was our choice. That was 767 or the other one. Anyways, yeah.
Okay, you have to know. I worked at an airport for 2 years, so I know the different types and
okay
through binoculars to identify which type it is. So yes, I've got experience with that.
Calculations are good, but visual is better. Like to really show that it does do what it says it's doing. But tracking the camera, the PTZs, the fast Daiwas, will track the cameras. Like it's staying pretty centered in the picture, and yet that's an airplane moving. The first one I showed you. So, what can I say? That's the airplane, and it's moving it. You can tell by the clouds. The camera's moving. It's a little jerky at this point, and that's long ways away. This one. Very far away, and then suddenly this UAP comes into whoop, and it makes a quick little jog, a little closer than the airplane, but you get the idea. Okay, so now stop streaming. Did it stop? All right. Anyways, as I'm saying is, those calculations are pretty good. I like that tool. I hadn't seen that before. Thanks, Ron.
So what we've seen is the Dahua that you just mentioned with the 35 zoom, and
that
what
was
we saw
32 zoom.
32 zoom, and what we saw is on max zoom and whatever Boeing maybe with roughly 20-30 pixels, I guess, something like this.
Yeah, I'd say it was that much and then we zoomed into it. Yeah.
Okay. So yes, of course you can see that it is an airplane. But the question from yesterday, and I want to go particularly in this, is can you not only resolve an object like a plane in a certain distance, but also say what it is, what airplane it is, and maybe even what tag it is written on. So when you have, let's say, 700 pixels or so, then it's pretty good to read.
The only cameras that can do that I know of that we sell in our security solutions are so expensive. You're mortgaging your house, and they're up to 100 zoom, 100 times zoom. And I've got cameras that'll do that. I got a FLIR camera that's got almost the equivalent of 1,000 times zoom.
We're still look at this. We're still talking about this one, the Dahua 88845 QA.
That's
one.
45. That's 45 times zoom, the new one.
Yeah, it's a 248 focal length, 248.
Mm-hmm.
So this is here in the optical focal length, 248. So, and it resolves it with 302 on 30 kilometers distance. And Christian, it's not about automatic, an autonomous system. It's more, there is something in the sky and we want to turn a PT set to it. So you have to resolve it first with your naked eye. Means that you then manually go there and have to catch it somehow. And then let's say, like Dave said before, put a marker on it and the PT set tracks it by itself. So this was the question.
Yes, slowing it manually to it is fine, but the resolution doesn't fit. Because if you want to know what type of plane it is, you need at least how does the nose look? How many engines do you have? What is the tail looking? How is the arrowness of it? How does it look? Because without that, you can't do any classification, and therefore you need resolution.
And that's what we calculated here, Christian. Look at this. It
Yes.
resolves on 30 kilometers distance. It still resolves with 300 pixels. And 300
but with
pixels,
300 pixels, you can't do any geometry analysis.
I can, of course, read the tag signs on the wings or on the rear, whatever wing that is, the vertical one. I can read this. Tailfan, thanks. I can see what nation it is, for example. I can see what brand it is, if it's branded. And I can see if there's nothing. I'm sure with 300 pixels you can say whether it's the Air Force One. Yeah, let's do this. This is fun. So I look for the Air Force One plane.
It's a 747.
So let's
110 meters in diameter.
Let's take this one.
47400.
I didn't want this one. I want just the image copy. So there it is. Oh, it's mighty. So now I resize it to 300 pixels. Whoops. Okay, so this is 300 pixels. When I go at full screen, you can still read United States of America. I just want to give this example what's possible to read in 300 pixels resolution. Because at 30 kilometers distance, that's doable with this camera. Has nothing to do with us, Christian. I was just going to answer a question in the community. Is this device capable of analyzing?
The main question is at what distance?
Yes.
30 kilometers, it's backyard. That for me it doesn't count because it's not far away.
But your question is not for the community question that was put yesterday. Yesterday it was put for something that is seeable with the naked eye. And beyond 30 kilometers, you don't see a plane with the naked eye. So this comes not even in question. So if you can see it with the naked eye, then it's closer than 30 kilometers. Okay? And then it resolves.
Then I do not need a scope to view it. I can take a binoculars and view it myself.
Yeah, but maybe they want to have a higher resolution if it comes closer. Maybe they want to automatically record. I don't know. I think that the kick is that when you have found it and caught it with your manual, then you switch over to automatic to keep it in the eye as it moves over the sky. And at a certain point in time, then the let's say the perspective on the object is in a way that you can read the sign. And that's all what the question is of yesterday.
Yeah.
But I give you
with that camera, but
I give you I agree totally with you because our benchmark is the ISS and it has an angular resolution of 53 and it runs at 422 kilometers distance. It can still resolve the optic, and it can still resolve the ISS with 32 pixels. when the ISS is exactly at 420 in zenith. Of course, when it goes into, let's say, multiply by 1.4, let's say 560 kilometers, when it's on 45 degrees, then it goes down to 24 pixels. I think that this...
for detecting it, that's there. It's enough. It's good enough.
Yeah.
But for receiving and doing, let's say, geometry analysis, that's not good enough.
Yeah. Yeah, so actually that's what we wanted to have discussed, and I hope we could explain it. Maybe Nick or Carlos, do you have any questions about this calculation here? Is something not clear, not logic?
Yeah, I didn't follow up. I think the question was in the forum that they were asking, but is it for our camera or
No,
is it for their camera?
it's for their camera.
Oh, for their camera, yeah.
Yeah. So they wanted to ask us whether this camera is sufficient to reckon airplanes when you see them. So when you see on the horizon there's something moving, you take your manual PT set, control it to zoom in, and then keep it in focus in the center with this automatic motion detection, and watch it as it flies over the sky. And at a certain time, reckon it by human eyes what it is. It's a totally different approach. It's nothing about an automated system like ours. It's you can say it's a field equipment. So someone goes at a certain place and has certain people around them with a lot of equipment, and this is just one of the equipment. So that's why we played this through here and just wanted to see how many pixels is it resolving on this particular camera, which is built in this the camera. So, but basically about this calculation page, do you understand what the use is and how you
Yes, yeah.
Okay, so with this video, I think we covered everything. If there's no other question, then I would say we close the recording. Okay, bye-bye.